x, you can see this is our del psi by del x, that is minus sin x. So put the value here, minus sin x, and this is del phi by del y. What is del phi by del y? That is cos y. So put that two values, minus sin x minus cos y dx dy. So this double integration, minus will be outside from the integration. So minus integration from 0 to pi, 0 to x upon pi, then sin x plus cos y dy dx. Now first we have to integration with respect to y. Okay, so integration of sin x with respect to y, that is y into sin x, and integration of cos y with respect to y, that is sin y, and our limit of the integration is from 0 to x upon pi. So put x upon pi first instead of y, so that's why we get minus integration 0 to pi x upon pi sin x plus sin x upon pi dx, right? Now next is we have to integrate with respect to x. So here integration x sin x 1 upon pi will be constant, so that will be outside from the bracket, minus 1 upon pi integration from 0 to pi x sin x dx minus integration 0 to pi sin x upon pi dx. Okay, now what is the integration of x sin x? Here we have to use integration by parts. So x is as it is, the integration of sin x is minus cos x, then minus derivative of this x is 1, and then integration of this minus cos x, that is minus sin x. Okay, so here we have to use integration by parts formula, which you already studied in the 12th standard. So so this bracket is exactly the integration of x sin x minus integration of sin, that is minus cos x upon pi, and the coefficient of x is 1 upon pi, that is upon 1 upon pi, so pi will be in the numerator. So the final answer is pi into minus cos x upon pi. Integration is 0 to pi. Now put first of all pi instead of x, so what you will get? Pi into minus cos pi. Okay, so pi into minus cos pi, that is cos pi is minus 1, so that's why we get 1 upon pi, this minus 1, right, and this is also minus 1, so minus 1 and this is minus 1, so we get pi into minus 1. Then this is 0, when we put 0, this is also 0 and this is also 0, so only the terms remaining is pi into minus 1 plus, now put the value pi here, you get pi will be outside, plus pi into cos 1, right, this minus 1 into this minus 1 and minus 1 become plus, so cos 1 and put 0, so you will get minus 1, right. So the final answer is minus 1, this pi will be cancelled out, minus 1 plus pi cos 1 minus pi. So pi cos 1 minus in bracket pi plus 1. So this is the final answer, which is the required. So here they complete the solution of this question. We use the Green's theorem here, and to solve the value of this integration using the Green's theorem, here is a question. I repeat that here is a question using the Green's theorem. We will let the line integral and we find this integration using the Green's theorem. This is the statement of Green's theorem, and other one are all just a numerical part, right, so that you can understand. Just this is just a simple double integration which you already study in your first semester in calculus. So next question, question 3c. The velocity vector v, that is equal to r of t, that is equal to x cube k of a fluid motion is given. Is the fluid irrotational? The first question. The second question is incompressible, and then find the path of particle, right. So here is a question. Here v is equal to x cube k. So first of all we find curl of v, that is equal to determinant of I j k The second row is del by del x, del by del y, del by del z, and what is our v? V is x cube k, right? So the third row is definitely, because the coefficient of I and j both are 0 here, so that's why 0 0, and then coefficient of k is x cube, so x cube. So the final answer is, when we solve this determinant, 0 minus j into del by del y of 0 minus j into del by del x into x cube, so that is 3x square, right? That is not equal to 0, so that's why v is not irrotational. But divergence of v, when divergence of v is equal to 0, del by del z of x cube, that is equal to 0, clear? So that's why v is incompressible, that is correct. And the path of particle is given by r of t is equal to integration r dash t dt, that is equal to k bar integration x cube of t dt, right? So here is the answer. The answer of this question is the v is not irrotational, but v is incompressible, and here is the path of the particle, right? So this question was asked in 3 marks in this question paper. And the next question, question 4a, the first part. Let P1 is equal to 1 plus x, P2 is equal to 1 plus x square, and P3 is equal to x plus x square. Show that the set S is equal to P1, P2, P3 is a basis for P2. And find the coordinate vector of P is equal to 2 minus x plus x square with respect to S. So here is the, and this question was asked in 5 marks. It's quite interesting. See, here we have 3 polynomials which are polynomials of P2. P2 means set of all polynomial of 2 degree, right? So, and S is a set P1, P2, P3. We have to prove that S is basis for P2. So, and then find the coordinate vector of P with respect to the set S. So the first target is to prove that the set S is a basis for P2, right? Now here we use one important theorem. Now what is the definition of basis? The definition of basis, we can say that B is any set, right? B is called basis for the vector space V if B is satisfied the following 2 conditions. What is the conditions? What are the conditions? The first condition is B is linearly independent, and the second condition is B spans the vector space V. If one of the condition is dropped, then we can say that B is not a basis for vector space V. But here we use one important theorem. Now what is the theorem? Says that, try to understand. Here we use one theorem that if dimension of V is equal to n and S contains exactly n vectors, right? Dimension of V that is equal to n and S contains exactly n vectors, then S is basis for V if and only if S is linearly independent or S spans V. That means what? We don't need to prove both the conditions, only the one conditions. Using the one condition, the second one is automatically satisfied, and using proving that one condition, we can say that B is a that set is a basis for the vector space V. So that's why we use this important theorem. So same situation happen here. You can see dimension of what is our vector space? What is our vector space? V, P2, right? All the polynomials are from P2. So, and we know that dimension of Pn is equal to n plus 1. That you should know. Okay, some dimension of some basic vector space. That means dimension of Rn is equal to n. Dimension of set of m cross n matrix, that is equal to m into n. Dimension of Pn is equal to n plus 1. So I hope that you should know some of the dimension of some of the basic vector space, right? So same situation happen here. Dimension of P2 is equal to 3 and S contains exactly 3 vectors, 3 polynomials, correct. So that's why we can use this theorem here also. So we only need to prove S is linearly independent. Because of to prove linearly independent, it's quite easy, right? Because of we have 3 polynomials, we can use the determinant. If determinant is not equal to 0, right, then we can say that the set S is linearly independent and set S is a basis for vector space V. So that's why here we use this determinant. Now the first row is coming from the first polynomial 1 plus x 1 1 0. The second row is coming from the second polynomial 1 0 1, and the third row is coming from the third element 0 1 1. Okay, so that is equal to 1 into 0 into 1 minus 1 minus 1 minus 1 into 1 into 1 minus 1 into 0. So that is 1, that is equal to minus 1 minus 1, that is equal to minus 2, not equal to 0. So S is linearly independent. Now S is a basis, right? So S is linearly independent, and using that important theorem we prove that S is a basis for the vector space V. Okay. Now we find the coordinate vector of P, that is equal to 2 minus x plus x square with respect to S. Now 2 minus x, how we find? This is our polynomial 2 minus x plus x square plus a into P1 plus b into P2 plus c into P3. This bracket is actually P1, P2 and P3, right? These 3 brackets. So a into P1 plus b into P2 plus c into P3, and we have to find a, b, c, right? That is our coordinate vector. So first of all we write the constant term, constant part, that is a plus b plus a plus what is the coefficient of x from the right hand side? A into x plus c into x. So a plus c into x, right? And what is the coefficient of x square in the right hand side? B plus c, okay, b x square plus c x square. So that is b plus c into x square, correct. Now so a plus b plus a plus c into x plus b plus c into x square. So a plus b is equal to 2. Comparing this two part, left hand side and right hand side, a plus b is equal to 2, a plus c is equal to minus 1, and b plus c is equal to 1. Okay, so here is the 3 equations. A plus b is equal to 2, a plus c is equal to minus 1, and b plus c is equal to 1. Now how we solve these 3 equations? Basically we have to find a, b, c, right? And these 3 are linear system of equations with the 3 unknowns and 3 equations. So we can definitely use the augmented matrix to solve these equations, right? So let's see how we find a, b, c. Here is the first row is coming from the first equations. 1, the coefficient of a, b, c, that is 1 1 0. So 1 1 0. The coefficient of a, b, c in the second equation, that is 1 0 1, and the coefficient of the third equation is 0 1 1, and this column 2 minus 1 1, that is exactly the right hand side part of each equations, that is 2 minus 1 1, right? Now we have to convert this augmented matrix into a row echelon form, and that you should know that how to convert any matrix into a row echelon form. There are 3 conditions to become a row echelon form. First condition is if there is any 0 row, it should be the bottom of the matrix. The next condition is whatever our leading entry in any row, below that leading entry in that particular column, all the elements should be 0, right? So leading entry is first non-zero element of the row, sometime we call pivot. So below that leading entry all the elements should be 0, that is the second condition. And the third condition is if whenever we are going from above to below, right, our leading entry is going from left to right. Okay, whenever we are going from above to below, our leading entry is going from left to right, correct. So here is our matrix. We have to convert this matrix into a row echelon form. So first we have to multiply first row with -1 and add into the second row. This is our leading entry, so I won't make 0 here. So the next process is we multiply first row with -1 and add into the second row. So R12 -1. So the first row and third row are as it is, 1 1 0 2. The second row become, you can understand from this matrix, 1 -1 0, 0 -1 -1, and then 1 minus 0, that is 1, -1 -2, that is -3, 0 1 1 1, correct. Now the first row is 1 1 0 2, the second row is 0 -1 1 -3. Now the next process is, this is our leading entry, -1. I won't make 0 here below that leading entry. So what we have to do? We have to multiply second row with 1 and add into the third row, right? So the third row become now 0 plus 0 0, 1 minus 1 0, 1 minus 1 plus 1 2, 1 minus 3 minus 2. Okay. So the first row is 1 1 0 2, the second row is 0 minus 1 1 minus 3, and the third row is 0 0 2 minus 2. Now this matrix is in row echelon form. See, this is our leading entry. In the first row, below that leading entry we have 0 here. In second row, this -1 is our leading entry. Below that leading entry we have 0 here, and there is no 0 row. Okay, there is no 0 row. Okay, so if suppose there is any 0 row, it should be the bottom of the matrix, but in this case we don't have any 0 row. So this matrix is now in row echelon form. So now we can solve easily these three equations. From the first row we have equations a plus b is equal to 2, right? A plus b is equal to 2. The second row, from the second row we have minus b plus c is equal to minus 3, minus b plus c is equal to minus 3, correct. And from the third row is 2c is equal to minus 2. So c is equal to minus 1, put that value in the second equation, c is equal to minus 1. So minus b plus c is equal to minus 3 and c is equal to minus 1, put the value here. So you will get b is equal to minus 1 plus 3, that is equal to 2.